We are going to review different types of factoring today. So given each function, we want to completely factor and find the zeros. So for number one, we have f of x equals 36x squared minus 7x minus 4. So how you know you can factor a trinomial? If whatever your highest degree is, if the middle degree is half of it, so this is degree 2, and then this is degree 1, so half of the biggest degree, and then your last term needs to be a constant. Okay, so any trinomial where whatever your biggest degree is, the middle term is half of it, and then the last term is a constant, is a trinomial you can factor. So on this one, okay, this one's going to factor. If a quadratic trinomial does not factor, you're going to have to do the quadratic formula. But if we give you a trinomial with these bigger coefficients, it's not anything we expect you to do the quadratic formula with. These will always be factorable. Okay. So to factor, you want to look at your first term. Okay, so we want to look at multiples of 36x squared. So normally I would try 6x and 6x, okay, but then we're going to take our constant term and find multiples of that. Well, multiples of 4, that's just 2 and 2 and 1 and 4. Okay, and there's no common factors in this trinomial. Okay, if there was, I would take out a GCF. So you always want to make sure your trinomial doesn't have a common factor. So the reason I can't try 6 and 6, I'm going to go ahead and write this down, but normally I would just skip over it. Okay, if I were trying factors of 4 and 4, okay, or sorry, of 4, if I were trying 4 and 1, okay, I can't put the 4 here because I'd be able to GCF a 2 out of this when I can't GCF a 2 out of the original. Same thing, that's why I can't try 2 and 2 because nothing would be able to go with the 6. Okay, so on this one, I know that I can't try 6 and 6. So I'm going to try a different set of multiples for 36. I'm going to try 9 and 4. I usually just work my way out from the center. So if this doesn't work, I might try 3 and 12. So again, then I'm going to try factors of 4, which is 2 and 2 and 1 and 4. Well, I can't try 2 and 2 because the 2 can't go here. So the only thing I can try is 4 and 1. Now, since they have to multiply to a negative 4, I know one of them is going to have to be negative. Okay, and then I also have to check that it works. So to check that this factor works, what you have to do is multiply the outside. So if I multiply the outside, that'll give me 9x. If I multiply the inside, that'll give me 16x. Okay. Well, I'm wanting these to add up to a negative 7. So I know that I'm going to need the 16 to be negative. So if I add those together, that'll give me the negative 7x for the middle term. So that means this 4 has to be a negative because that'll give me negative 16, that'll give me positive 9, which will add up to that negative 7x. Okay, so this right here is the completely factored form. So make sure when you're factoring a trinomial, you find what multiplies to the first term, the leading coefficient, what multiplies to the last term, the constant. Okay. Then to make sure your factors are right, you're just multiplying the outside 2 terms and the inside 2 terms. You're just checking like the O and the I steps of FOIL to make sure it does add up to the right number. Okay. So this would be our completely factored form. And then to get the zeros, you just set each factor equal to 0. So I don't usually write this out, but you're doing 9x minus 4 equals 0. And 4x plus 1 equals 0. What they mean by find the zeros is they mean find the x values. That's going to make the function equal to 0. Okay. So to get my zeros, I would just add 4 and then divide by 9. So that would give me 4/9 for the first one. Here I would subtract 1, divide by 4, and that would give me negative 1/4. Now let's go ahead and look at another trinomial example. So I have f of x equals 12x to the 4th plus 23x squared minus 24. Okay, so again, it's 3 terms. The highest degree is 4, the middle degree is half of it, 2, and the last term is a constant. So that means I can factor this one. Okay. So to factor it, I'm going to try multiples of 12. I'm going to start with 4 and 3. There's nothing wrong with starting with 2 and 6 and 1 and 12, but I usually start with the middle ones. And actually on this one, I know I can't start with 2 and 6, because if I have to find multiples of 24, that's always going to include at least one even number for the multiples. So if I have an even number here and I tried 2 and 6 for my x's, those are both even numbers, so it would always have a 2 in common with whatever I picked here. So I know I can't even try 2 and 6 on this one. So that's why I'm going to start with 4 and 3. If this doesn't work, I'll try 1 and 12. So since this is x to the 4th, I now need these to be x squared and x squared. So this leading coefficient, okay, you always break it up into the degree of the middle term, because if I multiply these together, that'll give me the x to the 4th. Okay. And then what multiplies to negative 24 is 4 and 6. But I can't put the 6 either place because it would have a GCF. If I put the 6 here, there'd be a GCF of a 2. If I put the 6 here, I'd have a GCF of 3. So I can't try 4 and 6, so I'm going to try 3 and 8. Okay, so I have to put the 3 with the 4. I have to put the 8 with the 3 because I can't put common factors together. So I can't put the 8 with a 4 because they have a common factor of 2. I can't put the 3 with this 3 because they have a GCF of 3. And again, it's got to multiply to negative 24. Okay. So first thing I'm going to do is I just need to make sure I can get this correct number. Okay, so one of these I know has to be negative to multiply to a negative 24. So I'm going to multiply the outside 2. So that'll give me 32x squared. And I usually just do this part in my head. You don't have to write it out. So that's 32x squared. That's going to be 9. I want it to add to positive 23. So I know the bigger number needs to be positive this time. Okay. So I'm going to make that a plus 8. So that'll give me positive 32. That'll give me negative 9. And then I'm going to check when I add these two together, it does give me this middle term. So that's how you know you've got the correct factors. Okay, now if these weren't the correct factors, then you would just try another set of numbers. Okay, like 2 and 12, but you can't put the 12 either place, so you would know not to try that. You can't try 1 and 24 because the 24 can't go either place. So if this had not have worked, then we would have tried a different set of numbers. We would have tried 1 and 12 for these first two terms. Okay. So this is the completely factored form. Okay. We're always going to factor down to at least something quadratic, meaning degree 2. Now, these are not perfect squares, so I can't continue to factor this. This isn't a difference of squares because this 3 is not a perfect square. We don't ever want to factor with like roots in our factors. And this one, this is a sum, so you can never do sum of squares regardless of what these numbers are, whether they're perfect squares or not. So this is our completely factored form. Then to get the zeros, we're just setting each of these factors equal to 0. So I'm just plugging in a 0 here and then just saying 4x squared minus 3 equals 0. So if I solve for x squared there, I would add 3, divide by 4. That'll give me x squared equals 3/4. For the second one, I'm going to get x squared equals subtract 8, divide by 3. Okay. Now I know I'm getting two answers from this because if it's an x squared, that produces two answers. So make sure when you take the square root of something to solve the x squared for x, you're always going to have a positive and negative square root because we're looking for what number squared will give us 3/4. Well, that'll both be the positive and negative answer. So then when you're square rooting a fraction, you take the square root of the top, which is square root of 3. You take the square root of the bottom, which is 2. You would simplify any radicals here if possible and rationalize if necessary. But this one is as simplified as it gets. Now, if I look at this second one, when I take the square root of that, I'm going to get x equals, again, plus or minus. So this time I have a negative in the radical. Okay? So that's going to put an I outside the root. So that's going to be like, I'm going to work this part out here. That'll give us I root 8, and then we need to simplify the square root of 8. Well, 8 is 4 times 2, and so the square root of 4 is 2. So we can take a 2 from this outside, leave a 2 inside, and then I've got to take the square root of the bottom. Okay. So I've simplified this root, which you want to do first, and then you can't have a root in your denominator. So I'm going to go ahead and rationalize. And again, you don't have to show this work for rationalizing or for simplifying the square root. You can go straight from here to here. So then for my last two roots, okay, to simplify this, when you're multiplying two radicals, you leave the radical, multiply what's in the root. Root 3 times root 3, that's just going to give us 3. That would give us square root of 9, which was 3. So these right here are my 4 zeros. Okay, so again, since this was x to the 4th, I have 4 answers. So I have the positive negative root here, so that's 2 answers. This is 2 more answers. Now let's look at one more trinomial. So we have f of x equals x squared plus 2x plus 3. Now, since this one doesn't have a coefficient, we can just do our old school factoring by doing what multiplies to 3 and adds to 2. Well, that's nothing. Okay, the only thing that multiplies to 3 is 1 and 3, and that adds to 4, or negative 1 and negative 3, and that adds to negative 4. So since this one can't factor, we're going to have to do quadratic formula. So, to review quadratic formula, hopefully you remember it, that's going to be x equals the opposite of b. So negative b means the opposite sign of b. And then we've got b squared minus 4ac, all of it is over 2a. So make sure you know this quadratic formula here. Okay. And a is always the x squared coefficient, b is always the x coefficient, c is always the constant. Okay, so here my a is 1, my b is 2, my c is 3. Okay, so since this one doesn't factor, this is what we call prime. So if I asked you to factor this, you can just put prime as your answer, or you could just box the original polynomial. Okay, that's the completely factored form. So now for quadratic formula, we're going to have x equals the opposite of b, so that's negative 2, plus or minus b squared, so 2 squared is 4, minus 4 times a times c, so 1 times 3, that's 3, all over 2a. So 2a is just going to be 2. Okay, so this is going to give me 12. So this will be 4 minus 12, which is negative 8. Okay, so when you're simplifying quadratic formula, you always need to simplify the root first. Okay, so there's a negative, so an I comes out. 8 again is 4 times 2. Well, square root of 4 is 2, and then that other 2 is going to be left in. Okay, so once you simplify the radical, that is when you can reduce it with what's on the bottom. So if both the first number and the radical coefficient, if all three of these are divisible by something, that's when you can reduce it. Okay, so our zeros are going to end up being negative 2 divided by 2, that's negative 1, plus or minus 2 divided by 2, that's just going to be 1i root 2. So this will be my 2 zeros, negative 1 plus I root 2 and negative 1 minus I root 2. So 2 zeros because we were solving an x squared polynomial.